as we progress through our property, I want to really drive the point home that what I think sets our facility apart is that we have so many different things and examples of wind power and solar power, as well as water conservation and forestry and agriculture, that it's really a different facility than a lot that focus on one or two types of maybe renewable energy or forestry and agriculture. This wetlands area is the collection basin for 10 miles of surrounding areas. It flows here. And what makes it the wetlands area is all of that water that comes in here holds up, and just through a natural process, it's cleaned and filtered. That's what makes it a wetland. Next time it rains, some of you might have noticed we have streams and dry stream beds running. That water will go into that aquifer and then eventually back into the Chesapeake. So it's important that it holds up here and we protect this so it does have that chance to naturally filter and get back into the Chesapeake and all the surrounding watersheds. You don't necessarily have to have a multi-$1,000 pump or $300,000 from the EPA to actually have an effect. This is something that you can put in place at your home or in your development. Up closer to the entrance of the property, we have a fruit orchard. Those are indigenous trees that we planted there. And all of these fields up here, like I said, are working farms. So there's fields on that side and the far side of the property that we have riparian buffers, forest retention areas at the base of each one of those to slow the flow, as we call it, into the aquifers, the ponds, the streams, the wetlands areas before they even get to the Chesapeake, which is our watershed. We have installed a 10 kilowatt solar array on the top of the office, and before anyone asks, no, that's not south facing. The office was built before we even thought about putting in a solar array. It is a passive system, meaning that it does not track the sun through the sky. But it has been performing up to, or at least the last time I looked, up to all of the specs and standards that it was set out to do. So it's producing very efficiently. During the winter, we haven't had any real problems with snow buildup, which is a question that I get asked a lot. Just the heat that's retained in the panels keeps the snow from really settling on them. Haven't had a whole lot of maintenance on them. But one of the things that I found interesting as they were installing this system was from the time that the idea was originally conceived to put this solar panel system up to the time that it was actually installed, the installer came back and said, you know, for the same price that we had originally quoted the system, we can put in a different panel. It costs the same, and it's going to increase your power output. And that's just, to me, an example of how quickly this technology is developing. And even now, they have more and more efficient, higher output solar cells. One of the large reasons that we installed both of these is for teaching purposes. And I tell people that are thinking about installing these themselves, that was a major reason that we wanted these systems here. And for our teaching purposes, this is as beneficial as when it turns.
On demand.
There we go. What that's doing right now is it is tracking. It's doing what's called tracking the wind flow. So if it is not sustaining a 4-mile-an-hour wind from one direction, so we may have good gusts, but if it's not sustaining a 4-mile-an-hour wind, the top of that turbine will turn to try and find the best airflow. A couple of other questions that I'm asked is it does not produce a lot of noise. As you can tell, it's clipping pretty good. Really, before any noise, I usually feel the reverb off the blades, which is pretty cool. And it's neat for kids to come out here and actually get to look up at something that they see in books. Our solar panels drastically outproduce our wind power currently. It's been difficult to maintain. And because of the software that is used to change the energy over to a usable power source, it's not actually outputting at the 10 kilowatts an hour that it should be. Another thing about this system that people ask, sometimes it will turn and it will completely stop. If our wind gusts get up and over 40 miles an hour, it will do a self-stop. It will turn into the wind, it will turn the blades into the wind, and it will shut down. Because there is a point that this system's motor will burn out if those blades are going too fast.